Millions of tons of industrial waste serve as the unexpected origin for the marbles that have become the childhood toys of millions. Why is such a vast quantity of glass debris diverted from landfills? It only looks obvious to bury these materials forever. But in reality, sharp glass fragments and shattered bottles are systematically collected to be granted a dramatic new life. Through a tightly controlled closed-loop industrial process, where heat, motion, and time are precisely regulated, these discarded materials gradually shed their waste identity and undergo a total physical conversion into perfectly round glass marbles. The process is only gaining momentum. One can notice how the equipment gradually sorts the raw shards by color and transparency. Giant metal containers vibrate as the glass fragments shift, preparing for a transition that requires temperatures exceeding 2,000 degrees. The camera glides along the conveyor belts where the jagged edges of industrial refuse are still clearly visible. Everything only gets more complicated. Because the glass must reach a specific state of viscosity, the furnace operates without a single second of downtime. The transition to the next level involves the complete melting of the fragments until they lose their original shape. At first glance, the liquid glass appears to be a chaotic mass, but in reality, it is a refined material ready for precise molding. But this is just the beginning. Automated shears cut the molten stream with a frequency of several times per second. One can notice how the red-hot droplets fall into the grooves of rotating rollers. The blades rotate ceaselessly, and the metal rollers move in a synchronized pattern to ensure that every sphere achieves a uniform diameter. The movement is continuous and rhythmic. It is visible how the cooling process begins as the marbles roll along meters of metal tracks. Each sphere loses its glow slowly, turning from a translucent orange to its final vibrant color. The finished product moves further along the production chain, leaving its origin as industrial waste far behind. The transformation reaches its conclusion, and the material is ready to move to the next processing phase without haste. $300 million in annual global revenue represents the hidden economic power generated by the production of marbles. Why is such an immense financial figure associated with these small glass spheres? It would seem they are merely simple toys or decorative items. But in reality, marbles serve as the most definitive physical evidence of industrial rebirth, as they are constructed entirely from recycled glass that can be regenerated an infinite number of times without any degradation in structural quality. One can notice how the recycling industry operates as a quiet but relentless global empire. Established manufacturing centers in China, India, Mexico, and long-standing specialized factories across Europe and the United States coordinate to maintain this massive supply chain. The equipment gradually processes mountains of discarded glass fragments, transforming waste into a standardized raw material. This process is only gaining momentum. 4 tons of glass must be melted every single day within a large-scale factory to sustain the required production flow. It is visible how the raw material enters the furnace, where extreme temperatures break down the solid fragments into a glowing, homogeneous liquid. The furnace operates without interruption, consuming tons of scrap to produce billions of individual spheres every year. At first glance, the production of marbles looks like a niche craft, but in reality, it is a high-intensity industrial operation that never stops. The melt flows steadily through automated feeders that cut the glass into precise segments before they are rounded into their final shape. Everything only gets more complicated as the logistics of distributing billions of units across the globe take over. The material leaves the furnace and takes on its final spherical form, transitioning into a calm stage as the glass cools and hardens. Thus, the recycled glass reaches the standard ready for its new life cycle, continuing the movement of the production chain. Tens of thousands of glass containers represent the starting point for a journey that transforms discarded waste into precision-engineered spheres. Bottles once filled with water, beer, or food do not simply vanish after their primary utility is exhausted, but instead quietly transition into an entirely new industrial cycle of existence. Why are these seemingly worthless piles of glass collected with such systematic precision across entire continents? One might assume that raw sand is easier to source, but the reality of modern recycling proves that used glass is a far more efficient feedstock for high-quality production. Automated return machines located in supermarkets and gas stations serve as the initial gatekeepers, utilizing integrated optical sensors and scanning systems to verify the material and color of every single unit. The machine confirms the validity of the glass in less than 3 seconds, issuing a small refund to the user to incentivize this responsible collection behavior. From these decentralized points, heavy-duty industrial trucks operate in a continuous loop, transporting tens of thousands of bottles per trip towards specialized recycling facilities. What was once categorized as ordinary refuse becomes a moving stream of raw material, flowing steadily toward a new industrial purpose. One can notice how the cleaning line activates immediately upon the arrival of the glass at the factory. Industrial vibrating conveyors begin to shake with high-frequency intensity, effectively knocking off deposits of soil, sand, and fine dust that adhere to the surfaces of the jars and bottles. Workers perform a direct visual inspection alongside the moving belt, using rapid manual movements to strip away any lingering paper labels or plastic remnants. Simultaneously, high-power magnetic separators operate without interruption, pulling out metal caps and microscopic metallic fragments that remain mixed within the glass stream. This specific technical step is absolutely critical, as even a tiny amount of metal entering the melting furnace can cause catastrophic damage to the refractory systems. At this stage, the glass must reach a level of cleanliness that borders on perfection. But this is just the beginning. The clarity, brilliance, and structural stability of the finished marbles depend entirely on the absence of impurities during these initial phases. Once the cleaning is verified, the glass moves directly into the chambers of industrial hammer crushers. One can notice the bottles dropping into the dark maw of the machine, where they collide repeatedly with high-speed rotating steel hammers. In just a few seconds, the intact containers are completely shattered into millions of sharp, glittering fragments, technically known as cullet. It only looks obvious that the glass should be broken, but in reality, cullet is the ideal form for modern recycling lines because it has already undergone a thermal cycle. Using cullet instead of raw materials reduces the energy consumption of the melting process by approximately 40%. Waste has now officially transformed into industrial feedstock, ready to re-enter the manufacturing cycle with maximum efficiency. After the crushing phase is complete, the cullet is redirected into an automated optical sorting system for refinement. The fragments fall onto high-speed conveyor belts and pass through sophisticated arrays of laser sensors and industrial cameras. The system continuously scans every individual shard to identify its specific color and detect any lingering non-glass contaminants. Brown glass, green glass, and ceramic fragments are recognized by the software in milliseconds. Compressed air jets are then triggered with millisecond precision, blowing each fragment into its designated lane with a sharp hiss of pneumatic pressure. This sorting process runs non-stop at speeds exceeding tens of thousands of pieces every 60 seconds. It ensures that the cullet is categorized by color with extreme accuracy, preventing a slight mix of colors from compromising the final recycled product. It gets more complex further on. After sorting, feed conveyors carry the cullet to be discharged into the industrial mixing system. Here, silica sand, soda ash, and limestone are precisely weighed according to a digital formula and fed into massive mixing chambers. The heavy mixing paddles rotate ceaselessly, blending the materials into a homogeneous state. One can notice how every piece of cullet is uniformly coated with the other dry components during this mechanical agitation. The entire process takes place within a strictly closed environment to prevent external contamination and maintain the chemical stability of the batch. Depending on whether the factory produces clear, colored, or lightweight marbles, the proportions of these ingredients are adjusted down to the kilogram. Even a slight deviation in the mixture can alter the hardness and forming behavior of the glass. Long before the material reaches the heat of the furnace, the final character of each marble is already being defined within these mixers. The prepared batch moves steadily toward the next stage of the production chain. 88 pounds is the standard weight of a single batch of glass mixture as it enters the industrial furnace. This feeding process occurs with relentless mechanical precision at intervals of exactly 20 minutes. Why must the feeding schedule remain so incredibly rigid? A deviation of even a few minutes would disrupt the thermal equilibrium of the melt. The furnaces operate 24 hours a day, 365 days a year, without a single moment of shutdown. It seems simple to maintain a fire, but in reality, the interior is a constant 2000 degrees Fahrenheit. This temperature exceeds that of flowing volcanic lava. One can notice how the heat in the immediate vicinity of the machinery climbs toward 3,000 degrees, making the environment almost unbearable. Workers are required to wear heavy fire-resistant suits and thick protective gloves to survive the thermal radiation. But this is just the beginning. Inside the chamber, solid particles gradually soften and bond, transitioning into a fully molten state. The material is held stable for several hours to allow trapped gases to escape to the surface. Technicians continuously monitor the flow rate and temperature sensors to ensure the amount of raw glass entering matches the volume of molten glass exiting. This precise balance is what allows the glass to achieve a perfectly uniform composition. Gravity pulls the glowing liquid straight downward through an orifice at the base of the furnace. Directly below, two mechanical blades move back and forth at extremely high speeds to intercept the stream. The equipment is continuously lubricated to ensure the blades slice the molten glass into clean individual droplets without sticking. Each droplet measures approximately 21/30ths of an inch in diameter. It gets more complex further on. 4 marbles per second are produced by this cutting mechanism under standard operating conditions. This equals nearly 240 marbles every 60 seconds. The size of the glass segment is determined by the specific synchronization between the flow rate and the oscillation of the blades. The camera glides along the path as these red-hot droplets are propelled into 2 guide tubes for transport. Immediately after leaving the cutters, the glass drops into a system of rotating spiral shafts. These shafts are 5 feet long and are synchronized in both spacing and rotational speed. Why are the droplets forced to spin constantly along these metal spirals? Without this continuous motion, the soft glass would develop flat spots or stick to the equipment. Rotation ensures the material redistributes evenly in all directions to form a perfect sphere. The process is only gaining momentum. The shafts provide enough time for the glass to cool slightly and lock in its spherical geometry. High-precision adjustments to the spacing between the rollers control the final diameter of the marbles. One can notice how the rotation also keeps the individual spheres separated to prevent them from fusing together while still pliable. 1 million marbles per day is the output achieved through this exact mechanical balance. While the glass is still hot and highly formable, metal oxides are introduced into the stream to create patterns. These oxides are fed through special ports near the orifice where the melt flows. Skilled operators control the volume and position of these additives to create distinct color streams within the base material. Artisans sometimes intervene directly at the rolling shaft stage for specialized product lines. Fine glass frit is sprinkled onto the moving spheres, or heated glass canes are touched to the molten stream. This creates the classic cat's eye patterns and swirling streaks seen in finished marbles. Because the colors do not fully blend, every single marble develops a unique internal pattern. Everything only gets more complicated. 65-gallon steel drums receive the marbles immediately after they leave the forming rollers. These containers are thick enough to withstand the intense thermal load of the collected glass. The marbles remain in these drums for approximately 24 hours to cool naturally. This slow dissipation of heat prevents thermal shock, which could cause the glass to crack or shatter. Water is sometimes sprayed directly onto the rollers by operators during the formation stage. This thin layer of liquid rapidly cools the outer surface of the marble to lock its shape while the interior remains soft. Following this rapid surface cooling, the spheres are channeled back into the steel drums. The transition to the final stage of the production cycle begins here. Workers unload the cooled marbles into wheelbarrows once they have reached structural stability. The glass is transported to a staging area where it is shoveled into pre-positioned sacks with fast, decisive movements. Each container is placed on a scale to verify the weight against industrial standards. The quantity is adjusted manually until the exact weight is reached. The mouth of the sack is straightened and fed into an industrial sewing machine to be stitched closed. This ensures the contents remain secure and do not shift during long-distance transportation. Sacks are then stacked in orderly rows within the warehouse, awaiting final shipment to the market. In some facilities, the marbles are instead diverted into cardboard boxes or mesh bags to meet specific distribution needs. The material reaches the warehouse in its final form, marking the end of the manufacturing sequence. From here, the finished product moves toward the consumer without further modification. Thus ends one of the key stages of industrial glass production. 197 inches is the length to which the artisan stretches the molten glass mass to create the internal foundation for these unique objects. Why is this manual labor preserved alongside high-speed, automated production lines? It would seem that machines could replicate any pattern with greater efficiency. But the complex internal spirals and layered depth of a handmade marble require a sequence of thermal manipulations that only a human artisan can execute with precision. Artisans craft marbles with special patterns entirely by hand to ensure every piece possesses a unique internal structure. The process begins after the glass has been completely melted within the depths of the furnace. One can notice how the artisan grips a long metal rod and dips it directly into the white-hot molten mass to gather a precisely controlled volume of material. At this specific moment, the glass glows with a bright orange radiance caused by the extreme temperature of the melt. The artisan allows the mass to cool slightly for several seconds before dipping it back into the furnace to coat it with an additional layer of molten glass. The process is only gaining momentum. This dipping action is repeated several times to increase both the physical size and the structural stability of the future marble. Once the artisan has built up the desired amount of glass, the glowing molten mass is rolled evenly across the surface of a flat metal plate. This rhythmic motion rounds and balances the shape, effectively forming the basic core. While the core remains hot and pliable, the artisan begins the delicate task of creating the internal patterns. At first glance, the application of color seems like a random occurrence, but in reality, every movement is calculated. Colored glass rods and small fragments containing metallic glitter are prepared in advance on a separate metal plate heated to a molten state. The artisan rolls the hot glass core directly over these decorative materials, which allows the colors and elements to adhere firmly to the surface. Everything only gets more complicated as the entire piece returns to the furnace, so the colored layers can fuse completely with the core. The camera glides along the workbench as an additional outer layer of clear glass is applied, sealing the patterns inside and locking the design permanently within the transparent body. This patterned mass is then attached to a round, disc-like tool positioned at the end of a metal rod. The artisan pulls the glass out slowly and steadily until it reaches a length of approximately 197 inches. During this controlled stretching, the internal patterns are elongated along the entire length to form a thin glass rod with a continuous design running through its center. It gets more complex further on. The long glass rod is placed onto a wooden surface where the temperature drops rapidly and the material begins to harden into a rigid state. After a few minutes of cooling, the artisan uses pliers to break the rod into short, uniform segments. Each individual segment contains a complete portion of the original pattern, serving as the decorative heart of a single marble. These segments are subsequently reheated using the focused intensity of a direct flame. One can notice that the artisan wears protective goggles while focusing the heat specifically on the pattern section. This is necessary because the colored glass possesses a higher melting point than the surrounding clear glass. When the material reaches the ideal level of softness, the artisan gently twists the segment by hand to influence the internal geometry. This cycle of heating and twisting is repeated several times to control the characteristic swirling lines that define the final aesthetic. The process is only gaining momentum as the fully twisted glass segment is placed into a mold to be shaped into a perfect sphere. The stem connecting the sphere to the rod is reheated and severed with pliers, followed by a final flame treatment that allows the surface to round itself naturally through surface tension. The completed marble is then transferred into an annealing furnace for a slow cooling process lasting several hours. This controlled thermal reduction releases internal stresses within the glass structure, ensuring the marble does not crack and achieves the required durability. The molten stream of production concludes as the glass achieves its final solid state. 100% of the spheres produced on this line are the result of an industrial system operating with near-perfect precision rather than luck. Why must the parameters of this process be so strictly maintained? It only looks obvious that glass can be shaped into a sphere easily, but in reality, any fluctuation in the thermal or mechanical cycle destroys the uniformity of the entire batch. The temperature is kept stable at a constant level to ensure the material retains the necessary viscosity for forming. The production line runs continuously and without a single pause throughout the day. one can notice how the speed of the machinery is calculated in advance to match the cooling rate of the molten glass. Every movement of the forming rollers is repeated millions of times without a single millimeter of deviation. The process is only gaining momentum as the raw material transforms under the influence of gravity and mechanical pressure. It is visible how the glass reaches a state of perfect synchronization across every single link of the automated chain. Only when these conditions are met can the substance become a finished product that is uniform, reliable, and consistent in its physical properties. The camera glides along the cooling tracks, where the spheres begin to lose their orange glow. Everything only gets more complicated when analyzing the mechanics behind the world's industrial operations. This meticulous control guarantees that the output meets the required standards for industrial and commercial use. Thus, the glass completes its transition from a molten mass into a solid, finished form. This stage of the manufacturing cycle concludes as the spheres move toward the final sorting bins.